Hey everybody, Mr. Morel here, and today in this video we are finally going to start merging some worlds. So in regular class we've been talking about systems of equations. With honor stuff for an entire trimester we've been talking about matrices. Our ultimate goal with a matrix is learn how to solve a system of equations with a matrix. That's going to be happening in the next lesson. For this lesson, in order to get there, we need to know how to convert a system of equations into an equation of matrices so that we can use some of the other stuff we've been learning about with matrices in order to solve them really fast. I'm kind of excited about that. So that'll be the next lesson, is how to actually solve it. Today, we're just going to learn how to convert a system of equations into some matrices. Now, to get there, I just wanted to quickly review how to multiply, because knowing how to multiply is going to be key, and it's really easy to forget. So remember, my trick that we've talked about is to slide the first matrix down just like that. And then, let me get my pen going here. Our answer is going to fit right. Oh my gosh. Our answer is going to fit right in this space right here. Okay. Oh man, that's beautiful. And then, remember, what we're going to do is there's going to be two numbers on this one, because this was a 2 by 2 times a 2 by 1. So we can multiply, and the answer is going to be a 2 by 1. Okay, so keep that in mind. We're going to do 1 times 5 is 5. 2 times 6 is 12. So this top number would be 17. And then down here, we're going to have 3 times 5 is 15 plus 24. Let me just jot that down so I don't have to do it in my head. Okay, yeah, so 15 plus 24 is 39. All right, now, before I can teach you how to convert a system of equations to matrices, I wanted you to consider this other example we've got over here. So same idea, let's slide this down here, and I'm going to set up my answer. Now, just trust me on this, I got to set up the answer kind of big. Okay, so we have our 1, 2, 3, 4 matrix times x and y. For the top one, because we know this is going to be a 2 by 1, what we're going to have is 1 times x plus 2 times y. So 1 times x plus 2 times y is x plus 2y. Okay, that's kind of interesting. Let's go ahead and try the other one. So down here, it's going to be 3 times x plus 4 times y. So down here, we would have 3x plus 4y. Now, I just want you to consider what we started with and what we're ending with, okay? So maybe I'll delete some of these lines, see if that'll help you see. Oh, no, I don't want to delete all of that. Shake it loose. Oh, whatever. Okay, so we started with 1, 2, 3, 4 as a matrix, and then a second matrix that's the xy matrix, and we ended up with two expressions. One of them was x plus 2y, and one of them was 3x plus 4y. Now consider that this almost looks like a system of equations. All we're really missing is a curly bracket, and then like some equal signs, and maybe a number over here. Like I can just make up a number, 3 and 7, whatever. So keep that in mind as we start now talking about how to convert a system. I'm going to guess you maybe already figured it out in your head. Okay, so if we're going to solve a system of equations with a matrix, we've got to learn how to convert it. So I just want you to think, maybe pause the video and think, if I was to convert this system of equations into an equation of matrices, what would it be like? And think about this one as our sample, only we're going to go backwards this time. So this was x plus 2y, 3x plus 4y, and up here we had 1, 2, 3, 4 times xy. Okay, so on this example we have 3x minus 2y equals 14, x plus 3y equals 1, and you might be sitting there thinking, okay, you can do it. Maybe pause the video and try, but here's exactly how you would convert it. You want to look at your coefficients. Okay, I'm getting a highlighter here. So notice our coefficients, 3, -2. There's an invisible 1 over here, a positive 3 here. That's basically going to be your first matrix. Now, there's a couple of things to keep in mind as we go forward here. First thing is, we've always got to have our x coefficients on the left, our y coefficients on the right. We're going to have the top equation, the first equation on top, and the second equation on the bottom. So basically, we could take this 3, put it here, take the next -2, put it here. The x has an invisible 1 with it, and then a 3. Next, in order for this whole thing to work, we have to have an x, y matrix just like this. And lastly, maybe you figured it out, we kind of combined the 2 equal signs into 1 equal sign, and we're going to take the 14 and the 1, and those are going to become the matrix out here. We just converted this system of equations into an equation, a single equation of matrices. Kind of cool. That's going to be our big trick here on how to solve a system of equations with matrices, is just to convert it first. All right, so I just wanted to say this is only going to work if your equations are written as ax plus by equals c. That's called standard form. You have to have your x number first, your y variable, so x with its coefficient plus your y plus the coefficient equals your constant. If it's not like that, then you're going to have to fix it. Okay, so here are going to be 3 questions. I'm going to invite you to maybe pause the video, try converting these ones. I do have some tricks hidden in here. And then I'm going to go through each of these and maybe give you some tricks of the trade. So go ahead and pause if you want. And maybe you've unpaused and you're ready for it. So we're going to go ahead and go over these 3 examples right here. So the first example is pretty straightforward because we have our x's, y's, equals, and then our constants. So this one's not going to be too tricky at all. My top x coefficient is -2. Pretend like that's legible. My y coefficient is a 3. Down here, I have a 10x and a -6y. Then my second matrix is always going to be my xy matrix. And then out here, we're going to have our constants. So -10 and then 50 like that. That first example, that was super duper simple. So nothing too exciting going on there. Second example is a little bit trickier. You have to be careful. X's have to go first and then your y's. Okay, so looking at this, you probably would want to rewrite this equation by swapping these 2. Or, I mean, you could write that whole thing out if you want, but if you're being really careful, you could just imagine, okay, the top x coefficient is a +3, the top y coefficient is a -5. They're already on the left side of the equal sign. And then down here we have a 2 and then a 3. Always your xy matrix in the middle equals -23. Oh, that's pretty. And then 10. Okay, so there's that one. Pretty easy. This last one's the toughest one. Now, I'm going to kind of go the long way on this first one, and then I'm going to give you a shortcut on the other one, because the whole point of a matrix is we want to be able to do stuff faster. So if things take longer, then what's the point? Okay, so here, let me copy and paste this equation down here. Oh, let's see. I should have planned for that. Okay, let me duplicate that. Okay, so we got this equation down here. Now remember, we have to have the x on the left side of the equal sign. Just think about that for a second. You can imagine mom and dad are in different rooms. This is something I say in my classroom. To get this -2x to the other side, we would have to add 2x to both sides. And then we could add a 2x right here. Okay. And so we would have, you can see it, I'm not going to rewrite it, 2x plus y equals 3. So that means our top x coefficient is a 2, our top y coefficient is a 1, and then we have a 3 out here. Let's put our x and y, because that's always going to be the same. Okay? Now here's my shortcut. This is how I kind of do it in my head. You might think about times in class where we were doing maybe a whiteboard activity with systems, and I had to solve 2 systems of equations in the time that you guys would be doing one on your whiteboard, because we always had 2 problems on there. I would always just run to my calculator and I would do this, and it would look like I was doing it in my head because I wasn't writing anything down. But no, I was just going through these motions that I'm about to show you here. Okay, so looking at the second equation, I know that my x coefficient is 1, and it's on the correct side of the equal sign. It has to be on the left side, so I could put a 1 right here. And then what I do is I just look at this, and I'm like, okay, well, there's a 2y, but it's on the wrong side of the equal sign. So Obviously, the long way is we're subtracting 2y from both sides of the equation. I just look at that and I say, okay, that's a 2y on the wrong side, so that must be a negative 2 in this spot right here. Then we have a 14. It's on the correct side of the equal sign, so we're going to have a 14 over here. Okay, so that's kind of my trick, is I just know that I need x's in the left, y's on the right of this first matrix, and I look at the equations and I just say to myself, is that thing, oh, and our constants over here, is that thing on the correct side of the equal sign or not? If it's on the correct side, meaning that we're following the standard form, so if the x's and the y's are on the left side, you just keep the exact same number. If it's on the incorrect side, you're going to change the sign and put it in that matrix there. Okay, I hope that helped. Oh, I'm so excited for the next lesson, because all that substitution and elimination and graphing, we're going to be able to just throw these things in our calculator and do it lickety split, and it's going to be awesome. I'm excited. Okay, thank you guys for watching. I will talk to you later. Bye.